Welcome to the DIY Honda Garage channel. This presentation addresses the DTC P1659, indicating a malfunction in the Electronic Throttle Control System, ETCS, in a 2023 Plus Honda CR-V. The ETCS is essential for controlling engine throttle position with precision for optimal performance and fuel efficiency. The Powertrain Control Module, PCM, manages this system, ensuring smooth acceleration and engine response. A failure in this system can lead to unresponsive throttle control, which is critical for safe driving. The PGM-FI subrelay plays a key role by supplying power to the PCM for throttle control operations. Understanding this issue is crucial for timely and effective vehicle repair. The DTC P1659 refers to an electronic throttle control system malfunction primarily linked to the PGM-FI subrelay. This relay is crucial as it supplies power to the Powertrain Control Module, PCM, enabling it to perform throttle control functions. Typically, this relay is located in the engine compartment and is designed to engage when the vehicle is powered on. If the PCM detects that there is no voltage supply despite the relay being active, it stores this error code, considering it an anomaly in the system. This malfunction can directly affect how the vehicle accelerates and drives, necessitating immediate attention. Several potential causes may lead to the DTC P1659 being triggered. Firstly, if the PGM-FI subrelay itself is faulty, it would fail to supply power appropriately to the PCM. Secondly, there might be electrical circuit issues that hinder the flow of electricity, which can include shorts or open circuits within the system. This failure can affect the connections between various components, such as the throttle body and the PCM. Lastly, a malfunctioning PCM itself may also be a reason for the error, as it is the brain of the vehicle responsible for throttle control decisions. Diagnosing the exact cause is critical for proper repair. When experiencing the DTC P1659, drivers may notice several significant symptoms. The most prominent is an unresponsive throttle, where pressing the accelerator yields little or no acceleration response. Additionally, the check engine light will typically illuminate on the dashboard, alerting the driver to a fault within the engine management system. There may also be notable engine performance issues, such as stalling, rough idling, or hesitations during acceleration. These symptoms are critical to recognize as they indicate potentially dangerous driving conditions requiring immediate investigation. The first step in troubleshooting DTC P1659 involves turning the vehicle ignition to the on mode. It is essential to ensure the power supply is adequate for proper system operation. The next action is checking the voltage at the PGM-FI subrelay to confirm whether it is working correctly and providing the necessary voltage to the PCM. If the relay is functioning, but the voltage is not present at the PCM, further inspections will be necessary, focusing on potential circuit issues. This step is critical as it sets the groundwork for identifying whether the problem lies within the relay or the subsequent components. In this second step, the next circuit to inspect is the plus B dBW circuit, which supplies power to crucial components related to throttle control. Perform wire inspections to ensure there are no breaks or shorts, as any interruption can lead to loss of voltage. It is essential to check the integrity of the terminals and connections, looking for any obvious signs of wear, corrosion, or damage. If issues in this circuit are found, they can severely impact the performance of the throttle control system. Detecting and rectifying these problems is vital for the successful functioning of the vehicle's engine control. This step focuses on checking the FI/SUB RLYCL and its openness. Here, it is crucial to confirm that the resistance is below 1 ohm. which indicates a proper connection. Any resistance higher than this value suggests an open circuit, which could disrupt the relay's functionality. If the inspection yields abnormal resistance, it confirms that there is a problem within the circuit, which must be rectified before any further diagnosis can occur. This inspection helps validate the electrical pathways and ensures that the PGM-FI subrelay functions effectively. Moving on to the fourth step. The main focus will be the FI sub-Riley out circuit, which needs to be inspected for any shorts to ground. This involves checking that there is more than 1 mega-ohm of resistance, indicating that the wire is not inadvertently in contact with the vehicle's ground. A short circuit in this wire can create a significant malfunction in the throttle control system by falsely reporting conditions back to the PCM. If the resistance fails this inspection, further investigation is necessary to identify the root of the short and rectify it. Ensuring this wire functions correctly is essential for reliable throttle control. In the final step, you will inspect the powertrain control module, PCM, itself if all preceding tests indicate normal conditions. If the previous inspections show no faults, and yet the DTC remains, it is likely that the PCM has failed. The PCM is responsible for processing data from various sensors and controlling the throttle. So any failure here can result in serious drivability issues. Conducting further testing on the PCM will help determine if it is functional or requires replacement. It's important to ensure that all connections to the PCM are secure and that it is receiving power as expected for truthful results. Once repairs are complete, verification of the repairs is necessary to ensure everything functions correctly and that the error code no longer persists. Start by confirming all connections are secure and reassembled correctly. Clear the DTC from the PCM, wiping the error history and resetting any adaptive parameters the PCM uses for throttle control. Following this, it is crucial to conduct a test drive to confirm that the throttle responds accurately and that the vehicle operates smoothly without any disturbances or lagging. If all conditions are satisfactory, the DTC P1659 should not return, indicating successful repair. To prevent future occurrences of DTC P1659, it is advisable to engage in regular vehicle inspections focused on the throttle control system. Periodically checking the wiring conditions for wear and tear will be beneficial, as frayed or damaged wires can lead to serious issues. Additionally, test the PGM-FI subrelay functionality as part of routine maintenance to ensure it consistently delivers adequate power supply to the PCM. This proactive approach can help identify potential problems before they escalate, ensuring your Honda CR-V remains reliable and performs at its best. In summary, understanding DTC P1659 and its implications is crucial for the safety and performance of the Honda CR-V. Identifying faulty components, such as the PGM-FI sub-relay, and ensuring proper electrical connections can prevent significant vehicle issues. Regular maintenance and prudent troubleshooting steps can mitigate the risk of recurring throttle control issues, ensuring safe vehicle operation. Always prioritize vehicle checks, especially when warning lights are triggered. With thorough knowledge and proper diagnostics, any Honda CR-V owner or service technician can effectively address this error code and maintain optimal vehicle performance. Please like and subscribe to the channel. See you next time.